So, hello everybody, welcome again to one of the ODTN use case team calls. We've not been having these for a while because we have been busy for other things, but I'm glad that we're restarting this. So, just a reset of what the state of is of things. In the past few weeks, the two main elements that we have done for the project, as concerning myself and the community, has been the ONF Connect demo and the ECOC demo. So just a brief recap of what we did. For the ONF Connect demo, we achieved end-to-end connectivity among both the OLS with many transponders and the ROADMs with many transponders. I'm currently putting together a video of the demo, both from the Telefonica and the rack that I brought to ONF Connect, and that will be published. So that was good. Um, in terms of talks, there was some very good talks. There was some very good reactions from the people at the event. So I think we will see more and more interaction from the community coming up, which is very good. So I'm glad about that one. Two, at ECOC, I also presented the kind of the same demo, a little bit different twist on it, but it was the same hardware. It was more about uh, failover, where I could showcase the fact that ONOS can reinstitute flow rules among a device losing them. And can also be deployed in a 3-node instance. That was the focus of the ECOC demo. That also went very well, and I also had the opportunity to present ODTN at the TIP OPT group meetup. That was very good. There was some good feedback, and everybody appreciated the state of the project and how it is. Then everybody, I so there was some good feedback from the state of the project that the partially segregated scenario that we're targeting is the right way forward for the network operators that were present at the show, both ONF Connect and ECOC. There was some good discussions also with the TIP group in order to facilitate the integration of GMPI, and I will talk about that later, and maybe also Gert can comment on it. We had the in-person meeting for which the notes have been compiled down here, and that was also a very good meetup that sprung different thoughts and discussions, among which I got out mainly three of them to put in the roadmap. So the first few things that I think we should do as a project and as a team are the GMPI integration, which I will talk about now, the OpenConfig driver consolidation, and at least achieving FEC and bit error rate as parameters from the devices. So as a first thing, the GMPI integration has really been finally discussed, and there was a plan together. Thanks for the meeting with the GMPI group at ECOC. So it was me, Jan from Chestnut, who is now maintainer of the code, Gert from Juniper, and there was Gabriele from Cisco and Vittorio from Polytechnic of Turin. And the idea is that we now have a plan to do such an integration for TIP Summit and show a proof of concept of the integration at the TIP Summit event. The idea is that maybe not the best here, but so the idea for the demo plan and the integration plan is that we will provision the topology to both ONOS and GMPI out of band, meaning that at the moment is not ONOS provisioning GMPI with the topology, because that is, at the moment, unfortunately, ONOS does not have all those capabilities, and this first effort is also to understand what is clearly lacking in different components. And then also ONOS has the topology, goes and connects to the devices, exposes them as usual. That's the thing that we are currently doing right now. Then an operator comes with a request for ONOS from connectivity from A to B. That connectivity gets handed over to GMPI from a REST API that the guys from Chestnut are putting together. When that happens, GMPI does the computation that is with optical impairments and all the knowledge about the topology that it has, with loss, with all the amplifiers in the middle and all of that, the elements. And what then happens is that it gives back to ONOS all the paths with 1 over the OSNR. 1 over the OSNR, a complete list of devices that need to be traversed on the path, a wavelength that has been picked, and transmitting output power. There's been some debate among if we need or not need the transmitting output power to be included in this feedback from GMPI. Because in some sense, the optimization really happens during the amplification phase, and the transponder could send it out at maximum output power. But at the moment, we reached consensus that we're going to get a value, and that ONOS will provision that value from that received from GMPI to the transmitting transponder. Then the logic to pick the best path is going to be in ONOS. That will include either an operator margin or the possibility to choose based on either OSNR or length of path. Then ONOS will also pick the proper modulation based on the OSNR, and then ONOS will go down and provision intent with the wavelength and power and modulation configuration across all the transponders and whatever is in the middle. So this is the idea of the current integration, and the idea is to show it at the TIP Summit on top of 2 Cassinis and some checks like ROADMs, for which the driver has not been written, and the check like people will write it. The idea is to use this first integration to see what are the missing pieces in many of these elements. In the sense, what are the missing pieces in ONOS to really provision, for example, the topology to GMPI? What are the missing pieces in GMPI to better act as not only as a planning tool, but also as an online path computation element, basically? And also understand exactly what are the parameters that need to be exchanged to then move from probably a REST API that we will define for this demo to a fully blown open API, for example, TAPI, or for example, another Yang model that, or ITF or something else. So the idea is really to understand, make this first effort to understand and showcase the capability of doing it. And then after we understand, we have a phase 2 to better integrate this. Gert, did I miss anything, or was this a proper capture of the discussion we had at ECOC?
Oh, is it working? Oh, okay. Thank you. Yeah, that was proper caption of what we discussed at ECOC. Maybe one detail which is still a little bit under discussion on the PSE side, because what we have today in GNPY would also be able to do a path selection if needed. So whether or not this will change the picture needs to be discussed. We are not in that detail yet. But the rough outline, as you presented, is basically what we discussed at ECOC.
Okay. Yeah, I mean, if I am the one, if ONOS is the one to select the path, or GMPI is, to me is really only a matter of getting a path, and then I will use that path, or a list of paths, which will be then, I will then pick. So the difference is relatively small, in my opinion. And I think we will have a discussion later today in the call that we have set up about this with the people from TIP. And so the difference is relatively small, but I think that in general, this is the approach that we will take. Are there any questions about this from anybody else in the team that want to understand exactly why are we doing this? If that was a missing information, or have some suggestion what's best to do in this scenario.
Yes, Dominic speaking from. Yes, I have a small question concerning the topology, the internal network topology that you are going to use in order to compute the path from a PC function, I guess, that will be executed by ONOS. And yes, is there any work or working group defined to define that? Because I think GNPY will need at least to have some input coming from a network topology abstraction, at least.
Yes, indeed. That's a very good question, Dominique. Thanks for asking. The idea is that, so GMPy has, at the moment as a pull request, has not been yet merged, a topology definition model that is based on the ITF topology that extends it to include many of the optical impairments, such as loss of the fiber, and different parameters within amplifiers or devices. And I can link that model to everybody if that's of interest. So you guys can take a look at what is the topology topology description that GMPy expects to be capable of calculating those OSNR values.
Okay.
Andrea, it has the implementation from Orange?
No, that is not the implementation from Orange. I understood, at least if that is my understanding. So just to put everybody on the same page, Orange had an implementation that did half of what we're doing here, meaning the GNPY half, meaning that it was capable of, after being asked for an A to B path, outputting that path with the SNR value and stuff like that, and receiving the topology from a REST endpoint. But I think that after some discussion, and Gert, please correct me if I'm wrong, after some discussion within GNPY, that was not the proper way to go because it included a proper proprietary Yang model, and now instead they want to open up this Yang model and properly define it.
Well, I think we should define a little bit what means Orange implementation, and because I mean Orange is a very active member of GNPY, so let's say a substantial part of what we have in GNPY is also Orange. So I'm not sure what exactly the question.
So I believe what Kwan is referring to is
right. The pull
this
request for the rest. Yes, from Ahmed. Because I spoke to the Orange guys, and they mentioned to me about it. It's REST API.
Yes, so this one exists, and we let's say this is one of the discussions we also need to have internally in TIP. Let's say how to integrate it into let's say into GNPY. So it's still here on what you see, and there's discussion ongoing. So in my view, it will be integrated. It will be integrated soon. It will come up soon. But what you see here is also that on that API, for example, you get the topology information as well. So if we would use this precise API for the information exchange with ONOS, ONOS would need to provide the topology information. And in order to have a kind of a simple setup, we said that for the demo, we will kind of have a topology information in GNPY as a kind of a JSON file, which we read. So then there needs to be no transfer of topology information which is not yet there.
Yes, also, if I understand correctly, this was not done based it was done on these Yang models, but these Yang models were completely rewritten for GMPy instead of extending existing topology elements. So the other question I was sorry, go ahead.
But I mean, in a sense, there was no pre-existing element when we wrote it, so.
So
yeah, let's say it's work in progress, and we need to figure out what is the easiest way to move forward. Whether this is the work to be based on for the demo or not is simply something we need to decide together. That's basically what it is.
Because there is also another patch from Jan who shows a Yang model that I think is being merged. No? Okay. There is.
Yeah.
Where is this?
And I think we kind of moved it out to testing repository.
Okay. But point being, I can link that set of Yang files that actually extend the ITF topology. So again, the idea, we have a path to integration, and we have a call later discussing some of the details. But to answer your question, Dominique, I think that the topology will be provisioned out of band, independently of which exact way of the implementation goes, because at the moment ONOS has no information about loss, has no information about all the amplifiers, has no information about power range and things like that. Out of this exercise, we will understand what are the missing pieces within ONOS, and maybe within even TAPI, because we need a standard API, and then out of this come up with a proper design of the missing elements and go to the TAPI group and go to the ONOS implementation group to make that integration of the topology happen. Does that make sense? Dominique, did I answer your question?
No, it's okay.
We can hear you.
No, it's okay. I think you got the points to define. I think what needs to be done, as far as understood.
Hi, this is Jan. Can you hear me? I just joined.
Hello. Yeah, we were just discussing the integration that we were planning to do. I was trying to find the Yang files you wrote for the topology and the different elements that were needed, but apparently they're not here.
I think this is request 266. So let me find it and I will post a link to the chat.
Okay, thanks. So so the idea is that through this integration that we plan to do with GMPy, we will basically relieve ONOS of doing a lot of computation that otherwise had to be done internally, and having to account for all these parameters that at the moment ONOS does not have the capability to account for. And that would open us up for leveraging existing software that has been written, debugged, tested, etc., without having to rewrite our own piece for that. So I think this is good effort. There are a few things that needed to be taken care of in terms of implementation, both on the GMPI side and on the ONOS side. I don't expect it to be much work, but as soon as we smoothen out the details, I will come up with a set of stories for this implementation for the community to pick up. And if anybody wants to be involved in this implementation, I'll be very happy to receive any contribution to put in any work on this side. I'll probably work on it a little bit myself when the conference approach to make sure that the integration is smooth. And we will probably have to, as a first step, anybody who wants to try it will probably have to provision the topology out of band with the parameters of his network, basically provisioning GNPy as if GNPy was not connected to ONOS, but then the connection becomes available. Okay, so this is, thanks John for posting it to the chat. This is the patch that defines the different Yang models for the topology within GPY, and there's an example of the details here. I'll post it in the document so everybody can get an access to it, and take a look at it. Thanks for doing that. So if anybody has any more comments, I think this is a big addition to the ecosystem. And it's not that we were going to do it in just this month, because it's a first step within this month, but then we will have to extend it and harden it and test it more and include a complete feedback loop. Any questions? Yes. So
a good one. Is it possible currently with ONOS to provision just the optical path just into ROADMs, or is it like really integrated end to end? I know that I can do it end to end. I'm wondering whether it is also possible to provision just the optical layer without transponders from the UI.
From the UI, not at the moment. It is possible through CLI, our REST API. It's that just the UI is not there at the moment. So we can make it happen. We can make it happen if need be. I have a grasp on how it needs to be done. Problem again is time, and I much prefer showing the integration with GMPY, even if it starts through a CLI command, rather than not showing it and just showing a fancy UI. At least that's my preference, but I'll leave everybody to his own thoughts.
Yes, I'm here. I was just wondering how to best start with labs. But thanks, thank you.
Okay. Yeah, I mean, we can take this offline, and I can suggest you a few examples and a few possibilities. Okay. The other big topic is that out of ONF Connect, we augmented the drivers for different devices, and especially thanks to Paolo Gomes from Infinera, we got an Infinera Group G30 driver. It's currently not yet published, but I'm working with Paolo to publish it on Gerrit and review it and then submit it to the public people. But then after that gets merged, and maybe a few things that from Nokia in terms of power config, which we'll talk about later, there will be a need, and we have discussed this in person during our meetup, to do a bit of driver consolidation, because at the moment there is really a problem within the drivers. That is that there's a lot of copy-paste code or duplicated code, meaning that the drivers were not structured in a way that it allowed small methods to be plugged in where string parsing was needed. That is the big issue, basically, that each vendor has a little bit of different string parsing, and thus we got a proliferation of drivers. So I will create a few stories starting later today about this, and the idea is that what we want to do is take a look at every driver from OpenConfig that we have as soon as the Infinera gets in, and say, okay, these are the common pieces. Let's refactor them in a single class, and then let's enable in a proper way through code the integration of just one small little piece when it's needed, and this will enable to avoid bugs, to avoid duplication of code, and also to achieve that real goal of that one OpenConfig driver for everybody. So I'll put out the stories for this. Is there anybody who is or that is already interested in taking care of this that want to step up to do it? Oh, okay, I'll put out the stories and see who can do it. It's not the fanciest job ever, but I think it's very much needed. Another update that comes from ONF Connect and also ECOC is the Checklight Rodom integration. Jan, do you want to give us some thoughts on that?
Yes, sure. So our RODMs, they are often very open design. There was a talk at the ONF Connect explaining how it looks internally. There is also an open access journal paper. So if everybody wonders about the internal structure, it's available. The API is of course netconf, but the model is an internal one, which focuses quite heavily on just exporting the bare minimum to be able to work with media channels. So I plan to, or we at SysNet, we plan to contribute a driver. I expect that there are going to be some small impedance mismatches, which might manifest even at the small scale demo. Because, for example, right now I believe that that ONOS assumes that all of the RODMs are capable of setting, for example, channel power at a particular target. It's not a problem. We can do that, and the problem is that if there is a sequence of these RODMs, for example, let's imagine 10 of them, and the power gets dropped by, let's say, 1 decibel at the beginning. So it's a classic problem of PID controller. When the algorithm is distributed, it will essentially overshoot at the end. So it's just one thing to keep in mind, I guess. Yeah, this is it from my side.
Okay, thanks. Again, I think we can take this offline, but there are ways to avoid some of these things that you were mentioning, and there are also, we could also discuss that tuning power from ONOS is not strictly a requirement in this case, meaning that for a first demo we could just pre-tune or let ONOS tune the capabilities on certain ports, and that can be achieved through a driver. Basically filtering out the ports that are exposed but cannot have power tuned on them. And there are certain ways that we can do this. We can take this offline, but I think I think we can do it pretty easily. Okay.
Okay, thank you once again.
Okay, no problem. Another action item that I know Ivan, who's from Nokia, is on the call here, is power configuration for the Nokia transponders. So Ivan, do you want to give us an update on that? Hopefully you can unmute.
Hello one more time again. I was muted. So yeah, there is a small update on a power configuration. I was working on it. I tried to fix all bugs which I had. It looks like it's working. So that's basically it.
Okay, thanks. And I'm working with the Nokia group to make sure that this gets upstreamed as soon as possible, since it's very much aligned with with the ODTN scope of phase 1.5, since we will, it's basically transponder related. So look out for that in the upcoming weeks, I hope. There is also something else that we've been working on, is a CLI command to achieve cross connect in the RODMs. that might also help what I was discussing before with John. So the purpose of the command is just to cross-connect ports within the RODOM itself through the use of a flow rule. It will go back and reuse some of existing code in the RODOM service. So I think it's a pretty straightforward add, and thanks Ivan for taking care also of that element. Last thing on the roadmap, which I think will happen fairly soon, I hope, is work on the FAC and the bit error rate. At the moment, with the things that I've discussed before, I don't have any time to dedicate to these two parameters, but I hope that the community, you guys and the rest of the community, can step up and do what, for example, Sterling did for the modulation and implement this into ONOS. I don't know if Puneet, you guys are interested in implementing this. I'd be very happy to. You guys.
Yeah, I agree with Puneet.
Hello.
Yeah, so on BR, we guys are actually working on it. So you need to say the open config drivers for it, right?
Yes.
Yeah, so BR actually we are working on it, but in fact we haven't started. So we'll maybe confirm you in next call, right, about this.
Okay. I think that's something along the lines of module. This is a very simple parameter. It's not really configurable, at least from what I know. So it's going to be a simple matter of instituting a behavior that can actually read this, and then we can discuss on how to expose it. Probably the optical UI is the proper way to expose it, as we have added it in the past few months. So if you need any help on that side.
Yeah, so I think there are 2 points on it, right? So one is basically we have added these leaves in the open config, right? Yang models. So that is one part of it, and that we can actually, contribute. But another part is basically on the driver front. We are expecting the confirmation from the platform Cassini side as well, right? The ONOS. So I need to check that thing, and I'll confirm you maybe, later.
Okay. And I expect also on the Thai side that this is something that needs to be discussed, correct?
Yes, yes. Yeah.
Okay. Puneet, do you also want to share any feedback from either from ONNet Connect, from the people that you interacted with on the progress of the project?
Which you say the demo which we shown, or like what?
In general, if you got any feedback about the ODT, about the project, and what are the key points to be for the future, I would like to hear them out.
Yeah, I think the feedback was really good actually, right? Both on the demos, right, which we showcased, right? One is basically on your booth, and one is actually on our booth as well, where we showcase that in our solution we have used that ODTN in reference design, right, where the Cassini gonna be integrated onto the Thai part of it, and which is something which we contributed, and certain more parameters which we actually extended on the Thai layer as well. So yeah, that's actually really a good feedback which we got from customers as well as from the extended community members as well. It was a really a nice showcase, right? That I did.
Okay, it's pretty good. Thanks. Okay, so these are the things that I believe should be addressed very soon. The coming TIP Summit is at least the GMPI integration. I think that needs to be done, and the check-like loading integration. I'd like the consolidation to happen before the end of the year, if that is possible. At least that is my time frame for the consolidation of the drivers to happen. And then if that happens, I think that the goal for me would be to release an ODTN tag of ONOS with everything on top of 2.2 in order for it to be the golden standard for phase 1.5. So I think it would be a release of ODTN 1.0. Well, call it 1.0, call it 1.5 for an official tag of ONOS, Docker image and everything, just related to ODTN. Obviously, I'd like to have some help on that because there would be some backporting needed and some testing that needs to be done. So if anybody wants to step up and give me a hand on that, we can take it offline and discuss that release by the end of the year. I think that's the target. Okay. I encourage you, so I'll be publishing a video of the demo. I've been working on it. It's here, plenty of things that needs to be done still, but it's going to be a good overview of the ONF Connect demo. It will talk about both the rack present for ONF Connect and the Telefonica side of the demo. And I think that as we did for last year, ONF Connect, we put a stake in the ground saying at this point in time, we're capable of doing this, this, and that. So I think that this is the first few things that we need to work on for the next upcoming months. Is there anything that I forgot and people want to put on everybody's radar? I know there's a lot more, as you guys can see from the notes here, but I think these are the things that we need to focus on. If there is anything urgent, just let me know. Is there anything that I missed? Anything that you guys would like to include in this this sort of things that need to be tackled fairly quick? Okay. Then if not, I think we'll proceed on doing these set of elements. I'll proceed to do a set of Jira stories and assign them to different people depending on what needs to be done. So I'll revamp and relook at the Jira board so we can drop down on things that have been done and revamp on things that need to be done. Offline, I'll work with Jan and Gert on the GMPI integration, and I'll also work with Jan and the check-like team for the rodent drivers. I'll continue to work with the Nokia group for the power config on their transponders and the CLI. That side, I'll really like some help on the driver consolidation and the release. So if anybody wants, reach out to me. You know where to find me, and I'll be glad to hand that over to you with some guidance on what are, at least in my view, what needs to be done. Okay, that was all on my side. Is there anything else that you guys wanted to discuss today? Okay, then thanks everybody for joining. I hope that we can come back to these calls every week again, as we were doing before the summer break on F-Connect and ECOC. Also, if anybody's interested, some of this team will be present at the TIP Summit, so I'll encourage everybody who is interested in maybe meeting some of us and having some of the discussion on things that we will be doing in the ODTN project and the OPT group to come and join the TIP Summit the start of November. It's where we're going to showcase some of this stuff, and it's where there's going to be discussions around next steps of the integration. So I'll be happy to see you there. I'm gonna be going, and I know Gert, Jan are coming, so feel free to join. I'll be happy if we can have a discussion also over there. Thanks, everybody. Take care.
Thank you.
Thank you. Bye bye.
Thank you, Andrea. Thanks. Bye.
Thank you. Bye bye.